Yeah, my name's Richard Webb. For anyone who's not aware, I'm doing my PhD over at Iron Marsh. Today I'm going to talk to you about continuous subcutaneous insulin infusion therapy. Its long-term impact upon plasma, HbA1c, lipids, lipoproteins, and blood pressure. So, first of all, take it steps. What is continuous subcutaneous insulin infusion? Well, it's a therapy for patients who've got type 1 diabetes. So before I talk about that, I think it's better to give everyone a little background about type 1 diabetes if no one's sure about the disease. So basically, it's an autoimmune disorder of the pancreas where the body sort of attacks the insulin-secreting beta cells, which normally reside in the pancreas, meaning no insulin is secreted. So what? Why is that a problem? Well, we need insulin for various different roles in the body, but one of its key roles is in carbohydrate metabolism. Now what happens is when we eat carbs, such as pasta, rice, sweets, cake, whatever, ultimately it gets broken down into glucose, where it floats around in our blood quite happily. Insulin is also secreted. Now what insulin does, it acts almost like a key. It binds with these insulin receptors and allows these glucose channels to open, so glucose can pass into the cell, where it can be either stored or used as energy. If insulin is taken out of the equation, such as with someone who's got type 1 diabetes, it's quite simple what's going to happen. Glucose is just going to accumulate in the blood, which causes various sort of problems. I'm sure you're pretty well aware that this is often counteracted by simply injecting insulin. So, back to the original question, what's continuous subcutaneous insulin infusion? Basically, it's a small sort of pump that's given to the patients rather than the injections that they're used to. It consists of like a small sort of insulin cartridge, and the pump's attached to the patient 24 hours a day. This diagram sort of shows it, pretty simply. And it just basically injects people every few minutes with a rapid-acting insulin according to their needs. Now, it's often known as its abbreviation as CSII, or insulin pump therapy. I'm just going to refer to it as that for today because that's too long to keep saying. So, what's the benefits of it? The documented benefits are improvements in HbA1c. Now, what's HbA1c? It stands for glycated hemoglobin, and what it is you have a sugar molecule that binds to a hemoglobin molecule in your blood, and it remains there for about 8 to 12 weeks before it's metabolized. So rather than taking a blood sugar measurement, which can fluctuate all the time, a HbA1c measurement can give an indicator of a previous sort of 3 months average of someone's blood sugar. So that's kind of what it is really, it's like a 3-month average of blood sugar. So pumps can offer improvements in that, which is obviously good. Reductions in hyperglycemic episodes, what's lower blood sugar, which can obviously cause various problems. Reductions in insulin requirements, because on the syringes, patients have to have quite a lot of insulin. The sort of meta-analysis suggests that insulin requirements on a pump are 14% less lower, which is a benefit. There's also a decrease in the dawn phenomenon. Now what this is patients with diabetes sometimes secrete a growth hormone in the early hours of the morning, and this stimulates the liver to produce glucose, so they can wake up with quite high levels of blood sugars. But because the pump's connected to you 24 hours a day, you can set it so it pumps you with insulin through the night, so obviously you can wake up with quite a normal blood sugar, which is good. There's also various potential benefits, which my PhD is looking at, which I'm not going to touch on too much today, which is liberalisation of diet. In theory, pump users can relax their diet. Whether or not we do that, don't really know, hence I might be able to come back in a year's time and present some information on that. Same with quality of life. There's the potential for patients to enjoy a benefit in quality of life. Whether or not that happens, don't really know. I might be able to come back with some answers next year. And the bottom one, it can also offer potential improvements in the lipid profile. I've highlighted that in red because I'm going to talk about that in a bit more depth today. So why is that important? Well, cardiovascular disease is the major cause of death in patients with type 1 diabetes, unfortunately, and an abnormal lipid profile is linked to these risks. And it's also found in patients with more poor glycemic control. And previous research looking at patients' lipid profiles that I could find only looked at it for like maybe a maximum of a year, and we kind of noticed that at the Royal there was a lot of patient data hanging around that hadn't been looked at, which went back quite a number of years. So we sort of thought, why don't we do an audit of this data and see what sort of comes out? So that's exactly what we did. We got NHS audit approval. We went in, well I went in rather, took an 8-year patient lipid and lipoprotein data down, 4 years before going on the pump and 4 years after. I took 4 years worth of HbA1c, remember that's that 3-month average of blood sugar data after going on the pump. And I took 4 years worth of blood pressure data after going on the pump. Input it into an Excel spreadsheet and then took it over to SPSS and just did some basic descriptive stats. Just so you've got an overview of the sample population, I'll quickly skirt over this. There was 261 patients from the Royal that we used, 33.7% male, 66.3% female, and a mean age of 45. So what did we find? Well, looking at HbA1c, we can kind of see that over the first year, there was quite a dramatic reduction there, and it sort of tails off, and that's really good. It shows that people's blood sugar levels on average are sort of coming down while going on the pump. And whilst that's good, it's kind of nothing new. We kind of knew that the pump would do that. As I said before, it's well documented that the pumps help improve patients' blood sugars. So it's a nice finding, but nothing new. Now we've got some data on patients' lipids. Now, the graphs to the left of the screen are the 4 years prior to going on the pump, and the graphs to the right are 4 years after going on the pump. So if we look at, say, cholesterol, we can see that after the pump we've got quite a chaotic graph, a bit noisy. There's not a lot going on with regards to a trend or anything. After going on the pump, it's still quite noisy. We've got a downward trend, but it's not great. It's not showing a massive impact upon cholesterol. Triglycerides, however, show something a little bit more encouraging. We can see on the left that before going on the pump, we've still got these big excursions. However, after the pump, it starts to get a lot more sort of compact, a bit nicer, and there's a downward trend. And if we look at the numbers, you can see that before going on the pump, some people have got highs here of almost 1.6. Now, anything over 1.7 is classed as sort of abnormal. So we can see that after going on the pump, it's heading down to the 1.1, 1.0 range, which is well within normal. So that's quite promising. And something we thought of as well when looking at these sort of peaks and troughs is, I don't know this for definite, it's just an idea we were playing around with, maybe there's a seasonal thing going on here. You can see these spikes every 12 months, and maybe same thing with the cholesterol. Maybe that's to do with winter time, we were thinking. People consume a bit more, maybe around Christmas. Don't know that for sure, just an idea. So that's quite promising with the triglycerides. Now we go on to look at lipoproteins. Now, for anyone who's not sure what a lipoprotein is, it's basically a particle that transports cholesterol around the body. You've got LDL, which, just to put it simply, transports cholesterol to the arteries. And HDL does kind of the opposite, takes it away. So basically we want the least LDL as possible and the most HDL, because that's beneficial for us. Okay, so we're looking at LDL. It doesn't appear like there's a great deal going on there. The trends as well, quite noisy. Slight downward trend on the LDL. The HDL is a bit of a different story. You've got an upward trend before going on the pump, which is followed through after. A bit confused why that is, not too sure, but if you look at the numbers again, we aim to have people with a HDL of over 1. You can see that these guys have got 1.5 to 1.7, reaching up to 1.8, 1.9, so these are quite well protected individuals. Again, I'm not too sure why this is. Hopefully further research might help us to find out. In my study as well, we're going to be looking at the type of HDL. Maybe that's a part, maybe it's the type of LDL as well. So hopefully might be able to find some stuff out through that. So then we went on and took some blood pressure readings. These are a lot more encouraging and a lot more dramatic trends as well. You can see that from going on after the pump, both systolic and diastolic blood pressure goes down quite dramatically from sort of 130-ish down to 122, so well within the normal range. So that's really good. Same with the diastolic, it goes right down to well within the normal range. And that's really promising finding. Now, one hypothesis we've got for that is maybe that's linked to the HbA1c, as I showed before, going down. I can put this into sort of a simple analogy of being like, imagine an artery is like a hose pipe with water flowing through, and you put a load of sugar in it. What's going to happen? It's going to become like a gloopy, thick mess. It's going to be hard to flow down. You take some of that sugar out, it's going to flow a little bit easier. So I'm thinking maybe these reductions in HbA1c are also linked to improvements in blood viscosity, which are illustrated by these decreases in blood pressure. Again, I can't be too sure, but I've not measured blood viscosity, but just from these figures, it's a hypothesis. So what's going on here? Well, I've just mentioned HbA1c improvements, blood sugar improvements could be associated with some of this. I've just mentioned about the blood pressure. It's quite well documented as well that improvements in HbA1c are associated with improvements in lipid profile. So there could be a knock-on effect there. There's a decreased requirement of insulin on the pump, 14% roughly less, as I mentioned earlier. And that reduction in insulin has also been documented as a factor in improvements in lipids. So there could be something going on there. Quality of life, maybe people on the pump might be inclined to do different things if they're feeling better or less chance of having a hypo. Maybe they take up more sport, exercise. Hopefully my study might elucidate this a little bit more, but as I'm sure you're aware, that'll hopefully have improvements in lipid and blood pressure if they become a bit more active, etc. Kind of a similar thing with dietary changes. My study is looking at this predominantly, so hopefully I might be able to shed some light on that. Maybe going on the pump, you have some improvements in diet. I don't know, maybe not, maybe you have some negative things, but I'll have to get back to you. But I spoke to our clinician friends up at the Royal, and they think that it's something to do with quality of care. I've got people who are on the pump are a lot more intensively managed than people on injections. So they have more hospital appointments upon going on the pump. They see the clinicians a lot more, they're in contact with them a lot more. So that in turn might mean that the medication's a lot more intensively managed. For instance, if they're on a statin to manage the lipids, if they're on the injections and they only see the clinician once a year, it won't be changed until it'll just be changed annually. Whereas on the pump, if you see them every 3 months, it might be a lot more tailored to their sort of requirements. However, there's a few limitations with this audit we did. Primarily that medication data, I wanted to get hold of it because it's an obvious one, maybe medication is playing a contributory factor to this, but it was all held at GP surgeries, so it would really just been unfeasible to get it. Measurements such as lipids were often sort of self-reported as well, so there's quite an obvious limitation there. And statistical limitations, because of the data, quite a lot of missing data, so I've not been able to run the analysis yet. It's kind of still a work in progress. So all I've done is done basic means tests, which have obvious sort of limitations. So just to summarise, the pump has shown, according to this audit anyway, it's associated with improvements in HbA1c, improvements in lipids and lipoproteins and blood pressure. However, the mechanisms are currently sort of debatable, and further research we think is needed to elucidate these. So, thanks. And
Actually, spot on time, so that's great. I didn't have to shout at you. So, we've got time for a couple of questions. Oh, hang on. Oh, don't walk it. He's got a question.
Understood it. Is there like a cost question here, implication, in terms of a saving on medication, or is this more expensive? What's that kind of cost impact to the health service as well?
Yeah, well, there is a cost. It's quite a big cost. The pumps themselves are about £2,000 to £3,000. So obviously each patient you've got to pay out that. Plus you've got a lot of tubables. Like you've got the cannulas to fit yourself, the tubing that needs to be changed every 3 days. They can be quite costly. So although I said it uses less insulin, so you think you might have to save on insulin.
That's what made me think. Yeah.
You're going to have costs on disposables. So I think it's probably more expensive to be on a pump than it is to be on injections.
Martin's got a question for you.
So it's actually not the pumps themselves. How do they attach? Or do they wear them 24 hours a day?
Yeah, you do. As I said, you have like a little cannula, and it's got kind of like a plastic device, like a spring-loaded thing. And when you want to attach it to yourself, you can put it on your belly or your shoulder or wherever, and you pull these little wings out, press the button, and it injects it into you. Yeah. So you've got like a little sort of plastic syringe type thing inside. It's only about that big, it's tiny. And then you have a cord that comes off, which is attached to the pump. And then the pump, you can either put it on your belt, in your pocket, some women put it down their tops. So that's how it is, but it's attached to you all the time. If you want to play sports though or something, or go swimming or something like that, you can unattach it at the cannula, so you just have the little like plastery attachment attached to it. But you can only really do that for maybe about an hour, have it unattached, and then you've got to attach it again and inject yourself again, sort of thing.
So how do you attach it at night?
You have it in bed with you. You literally, I don't know, you can put it in your pyjamas or attach it to something. Some people say that in the beginning it's horrible in terms of like you're rolling over with this cable.
Yeah, see, that's what I'm wondering about patient compliance and things if it starts being quite
Well,
fiddly.
to be honest, the majority of them have said that you get used to it,
Yeah.
being in bed with you, and the compliance is high because the benefits far outweigh the drawbacks. So people literally would fight people who would try to take this pump off it because it's really improved their life so far, from what I found. Anyway.
Just one question. I mean, you mentioned right at the end, there's gaps in your data.
Yeah.
Are there not ways of doing statistics to counteract those gaps?
Yeah. I'll be honest. I've done quite a lot of reading on this, and I've found a model I can use, which I've done. I've done the analysis. I'm not confident it's correct. So there's no one in our department who can help. So we've been speaking to people.
Just appoint somebody in health, statistical intelligence or something or other, a new person. So obviously as soon as they start in September, you want to have a word. I don't know who it is, but people in health will know.
Because I have done the analysis and I've done what I think's right, but I've no one to say.
Yeah, is it right? Yeah.
I've just done what I think.
Yeah.
So I can't really write it up and try and get it into a paper with it if I'm not confident.
No.
The stats are any.
You'll have to wait till you find out. Right. Thank you very much. We haven't got time for any more questions.